This is a very common type of problem when you're dealing with exponentials and logarithms. It's an excellent one to get to know because it's like one of the keys to solving many problems. So knowing your laws of exponents, you should know that 2 to the x plus 2 is just equal to, well, this is 2 times 2 times 2 times 2. How many times? X plus 2 times. So if I do 2 to the x, that means so look at this is 2 times 2 times 2 times 2 x times, and this is just 2 times 2 times 2 times 2 x plus 2 times, so 2 extra times. So this is going to be times 2 times 2. Right? So 2 to the x plus 2 is the same as 2 to the x times 2 times 2. Right? It's just, this is 2 multiplied by itself, x times 2 times 2 times 2 times 2 times 2 times 2. There's an extra 2 there. Right? So the exponent law says that 2 to the a plus b is the same as 2 to the a times 2 to the b. That's another way of looking at it. It's just knowing that exponent rule. Okay, so knowing that, we can say that 2 to the x plus 2 is just 2 to the 2 times 2 to the x minus 1 times 2 to the power of x equals 96. All right, so now we could factor out a 2 to the x. So 2 to the x times 2 squared. Well, instead of 2 squared, I'm just going to write 4 minus 2 to the x times 1 equals 96. So 2 to the power of x is equal to 96 divided by 4 minus 1. So 96 divided by 3. 2 to the power of x is equal to, what's that, 32. Now I already know the answer because 32 is perfect. 2, 4, 8, 16, 32. It's equal to 5. But let's say we didn't know that. We can go on and say the log base 2 of 2 to the x equals the log base 2 of 32. And these log base 2 of 2 to the x, log base 2 and 2 to the something, those are inverses of each other, so that's just equal to x. X equals log base 2 of 32. Now let's say you have a calculator that doesn't do log base 2, you could just do log base 10 of 32 divided by the log base 10 of 2. And when you do that in your calculator, you will get an answer of 5. Voila. All right, like I said, one of the keys to look for is when you have these, the same base, or maybe you're going to have one with a base of 4 and the other with a base of 2, and you should recognize that as, 4 is just 2 squared. So a lot of times they'll try to trick you. They'll have a 4 to the x plus 3 and maybe a plus 2 to the x minus 3. And then you could just say, well, this is the same as 2 squared, which is 4, to the x plus 3 plus 2 to the x minus 3, something like that. And then this is going to be 2 to the 2x plus 6 plus 2 to the x minus 3. And then this is going to be, and you just keep working that way. So this is going to be 2 to the x times 2 to the x times 2 to the 6 plus 2 to the x times 2 to the negative 3. This will be 2 to the x squared, so 2 to the x squared. 2 to the 6 is 2, 4, 8, 16, 32, 64. Plus, this is 1/8 times 2 to the x. Right, so you could do stuff like this, and then you get yourself a quadratic here, and I don't know, there's a lot of things like that. So these are the sort of things you want to look out for. It's just you really have to know your exponent laws and try to get something common in all your terms. Okay, I hope that helped. All right, we got 3 to the power of 2x minus 5 to the power times 3 to the power of x equals negative 6. All right, well, 3 to the power of 2x is 3 to the power of x times 3 to the power of x. 5, 3 to the power of x. Let's say plus 6 equals 0. This is 3 to the power of x squared minus 5 times 3 to the power of x plus 6 equals 0. If this isn't factorable, I could just use the Pythagorean theorem, but not, sorry, the quadratic formula. Let's see if it's factorable first. So we got, this is 1 times something squared minus 5 times something plus 6. So let's say minus 3 minus 2. So this is going to be 3 to the power of x minus 3. 3 to the power of x minus 2 equals 0. Right, so 3 to the x is kind of like the variable. Right, like if this is saying, like this is a lot like saying 1j squared minus 5j plus 6 equals 0. So this is just j minus 3, j minus 2 equals 0. And so j equals 3 or 2. There's two different answers. Right, so here we're saying 3 to the x equals 3 or 3 to the x equals 2. Two different answers. Right, so for this one, x just equals 1. 3 to the 1 equals 3. This one's a little bit weirder, so we can say take the log base 3 of each side. So you're going to get x equals the log base 3 of 2. If your calculator's one that doesn't do that type of thing, you could just say the x is equal to the log of 2 over the log of 3. I don't know what that equals, but I'm sure you could pull that off. All right, hope that helped. All right, what do we got? 14a says 2 to the x squared equals 32 2 to the 4x. All right, 32 right away I'm going to recognize as this. So this is 2 to the x squared equals 2 to the power of 5 times 2 to the 4x. All right, we're going to use our exponent rule here. 2 to the x squared equals, I don't actually know them, so just in my head I go, this is going to be 2 times 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 4x times. So it's just going to be 4x plus another 5 times. So this is 2 to the 4x plus 5. That's how many times you're multiplying 2. You're doing it 4x times here, and you're doing another 5 times here. So 4x plus an extra 5. Right, let's get rid of that. Okay, so now if I just take the log base 2 of both sides, this is going to fall off on both sides. I usually don't do that. I'm just showing you why this works. You know, this exponent can come down to the bottom, and this is just equal to 1, right? This log 2 of 2 is equal to 1. Either way, these guys are inverses of each other. You got x squared equals 4x plus 5 for like 13 different reasons. Okay, so now we're just solving a quadratic. X squared minus 4x plus 5 equals 0. Quadratic formula, if you're not good at, this is going to be minus 5. If you're not good at factoring, x minus 5, x plus 1. Right, that doesn't work. Oh, sorry, this should be minus 5. And yay, now that does work. Equals 0. And so x just equals 5 and negative 1. You know, especially when you're working with logarithms, always check your answers, okay? These ones should both work. I'm just going to look at it, and yes, and yes. I'm just going to leave it up to you to do the check. Now let's go to, let's see if I could go to the next page on this. All right, let's go to part B. All right, 14b. We got 3 to the x squared plus 20 equals 1 over 27 to the 3x. All right, 1 over 27 I recognize right away as a power of 3. So let's go 3 to the x squared plus 20 is equal to 3. I know 3 to the 3 is 27. So 3 to the negative 3 is 1 over 27. And that's to the 3x. Okay, exponent rules. I think I know this one, but just to be sure and just to show you how I do it, let's say this is to the 4 to the 3. So this is going to be 3 times 3 times 3 times 3, 4 times. And then you have to do that 3 times. So 4 times 4 times 4 times, a total of 12 times. So it looks like the deal is you have to multiply these guys. So the same is going to work for these guys. So it's going to be 3 to the power of negative 9x. These are both base of 3, so you just take the log base 3 of each side, and that gets rid of these guys. So you just have x squared plus 20 equals negative 9x. Bring it to the left. X squared plus 9x plus 20 equals 0. It looks like a 5 and a 4. X plus 5, x plus 4 equals 0. X equals negative 5 or negative 4. Let's just take a look here. So this is going to be a positive something. Yeah, that should be all good. You don't have to worry about anything not working there, but I still would like you to plug them in and to double check on your own to make sure that they're both answers. Okay, hope that helps.